All right, Algebra 1B, welcome to the first part of lesson 7.3. We're going to be starting right around page 432, page 433, where you were in class today. So please open up your book to page 432, look again at the activity that you did in class, and just refresh your memory, whatever it is that you get around to watching this, refresh your memory about what you found in number 10, letter A, that pattern, okay? Take a minute, look at that rule, make sure you remember how you found it when you were working on that activity in class today. So number 10A, take a look at that, and then when you're ready, go on and we will look at our new rule. Okay, so, I can just go to the next page. There we go. More multiplication properties of exponents. We're going to go to page 433 and look at this new rule, raising a power to another power. Okay? And right here, this problem here is number 1 from your activity, or essentially it's number 1, except instead of a 4 in your activity, we now have an x. Okay? So we can see that x to the 5th to the 2nd is x to the 5th times x to the 5th. We know from our previous rule that when you see an x and an x, you are allowed to add the exponents. So we did that, 5 plus 5, which is the same as 5 times 2, which gives us x to the 10. Okay? So hopefully you reminded yourself of the rule that x to the 5 to the 2 is the same as x to the 5 times 2, which is 10. Okay? So to go from raising some power to another power, we just have to multiply those two exponents. Okay? You saw that in your activity, and now if we scroll down, or look down further in that page, you're going to see your rule right here. Okay? This is something to please add to your notes. Take note of this. Words. To raise a power to a power, all we have to do is multiply the exponents. Okay? So what that looks like algebraically with letters instead of numbers, a to the m to the n, some number to a power to another power, that equals a to the m times n, and then here's a whole bunch of examples similar to what you saw in your activity. So please add these three things to your notes, words, algebra, a couple examples, and then we're going to look at how this is going to work in your problem set in class tomorrow. Okay, so once you have those three things added to your notes, look with me at the top of page 434. So flip over a page, and we're going to look at problem 1 together. We should find that it is relatively easy. All right? Okay, problem 1. Simplifying a power raised to another power. This is the kind of thing that I am expecting you are able to do. Okay? Tell me what the simplified form is of n to the 4th power raised again to the 7th power. All right? We know from our rule that if I say n to the 4th power, raise it again to the 7th power, all I have to do is do 4 times 7 right there, and we get that that's n, whatever number that is, to the 28th power. Okay? So variable to the 28th power instead of to the 4th and then again to the 7th. Right? This works also for fractions, and we saw that in our activity as well. X to the 2/3 to the 1/3. They again want us to tell what is the simplified form here in problem 1b. So we look at what we're given, x raised to the 2/3 power, raised again to the 1/2 power. We know that when we raise a power to another power, all we have to do is multiply those two exponents. So that's what we're doing here. 2 over 3 times 1 over 2. I'm going to do that over here so I have a little more room. 2 over 3 times 1 over 2. Just as a reminder, when we multiply fractions, we just times across the top and we times across the bottom. We end up here at x to the 2 over 6. But we know that 2 over 6 can be simplified, so I want you to do that if you can. Simplify your fractions when you can. So we end up here at x to the 1/3 power. Okay? So all we did was multiply our two exponents because we took a power and raised it to another power. All right? Take a look for me, please, at the got it questions number 1. You'll notice something interesting happens in A and B, and then again in C and D. All right, so take a look at these, practice your rule a little bit, and then see if you can figure out if what you notice is always going to be true. Okay? So take a look at those problems, please. May take you a little bit of time, especially this reasoning part. When you have mastered that, come back with me, we'll look at the next example, and that'll be it, and we will be done. All right, so let's go on to the next page once you have those mastered. Pause the video, come back when you're ready. All right, so now we're going to put our 2 rules together. Okay, remember that when we multiply 2 things together that have the same base, we get to add the exponents. That's adding them, right? Plus. But now we're also adding in multiplying exponents when we see a power raised to another power like we see right there. Okay? So we're going to simplify that whole expression where we have 2y's raised to all kinds of powers. All right? And the first thing that you need to do, just like in the order of operations, before we get to add the exponents together, we have to do our multiplying first. Okay? So that's the first thing that they do here. Right here. They do y to the 5 over 2 times negative 2 because we raised a power to another power. Now, negative 2 is really like negative 2 over 1, and again, they just multiply their fractions across, and they end up at negative 10 over 2. That's right there. But hopefully we know that negative 10 over 2 is really equal to negative 5, right? Negative 10 divided by 2 is negative 5. So what we have now is y to the 3rd times, that's times right there, times y to the negative 5th power. Okay? But we know that if we're timesing 2 y's together that have different exponents, we get to add those 2 exponents together. Please, please, please don't multiply these. You'll get the wrong answer. Make sure that you are adding when you see 2 different y's. Okay, 2 y's raised to different powers. We add those together right here. 3 plus negative 5 gets us to negative 2. So now we're here at y equals negative 2. But you know that we hate negative exponents, right? So instead of saying y to the negative 2, we're going to use one more rule. And we're going to say, okay, y to the negative 2nd is the same as, put that on the bottom of a fraction, 1 on the top, y to the positive 2nd now on the bottom. Okay, so really, we didn't put 2 rules together here, we put 3 rules together here. Okay? And here they are. You multiply the exponents when you raise a power to a power. You add exponents when multiplying powers with the same base. And then you write expressions using only positive exponents. Okay? So that's the kind of thing I'm going to ask you to do tomorrow in your problem set, is put all of these rules together and see if you can get these to be nice and simplified with all positive exponents. All right? And I want you to try it down here. I want you to do letter A, and I want you to do letter B. You can skip letter C. We'll do more like that tomorrow. Okay? But please take a look at letter A, letter B. Become masters of those 2 problems and that whole process. If you don't understand any one of these rules that we use in this example, or how to use them here in A and B, please make a note to ask me that tomorrow in class. Okay? Once you have mastered those 2 problems, you will be ready to tackle your practice problem set tomorrow. Okay? So master those 2 problems. When you're done, you are ready to do your practice problem set tomorrow. All right? That is all I have for you tonight. Hopefully we can handle this. If not, please make sure you ask questions tomorrow in class. That's all for now. Have a wonderful night.